In this video, we're going to be treating images formed by plane and curved mirrors, as you can see on the board. Okay, now this is actually an aspect of physics that most students in particular, tend to find difficult. Okay, now it usually brings problem in the JAMB examination, the WAEC examination, NECO examination, and as far as JUPEB and 100 level examinations are concerned. Okay, now that is why I'm treating this aspect. If you've been having issues solving problems like this, you are in the right place. Okay, now before you can understand the image formed by mirrors, you need to know what a mirror is, or you need to know what mirrors are. Now, mirrors are simply glass surfaces that are coated to reflect, okay, or to reflect an object in order to produce an image. So whichever way you want to define it, okay, that is for the Englishman. Now in this case, we're talking about the properties of this particular instrument, that is a mirror, which could either be plane, as you are seeing here, or it could either be what now? Be curved. Now generally, there are two kinds of mirrors. We have the plane mirrors and we have the what now? The curved mirrors. Okay, now I'll come here and I'll write the kinds of mirrors we have. We have the plane mirrors, okay, and we have the what now? The curved mirror. Okay, we have a plane mirror and a curved mirror. Now from the name, you can get the definition of these kinds of mirrors. For a plane mirror, it is simply plane. That is actually the kind of mirror that you make use of in your house every day. It is usually circular, okay, but it is not bent. Okay, it could be circular or rectangular or square in shape. Okay, usually the mirror we have in our everyday house, the one we make use of. Okay, why for the curved mirrors? Okay, they are not used in our house every day, but they have their own applications, which we are still going to talk about in this particular video. Okay, now for plane mirrors, let's talk about the properties, or rather, let's describe a plane mirror. Okay, now there are some properties that are peculiar to plane mirrors. Okay, now for plane mirrors, take note that for plane mirrors, the image, or rather, when an object is placed in front of a plane mirror, okay, the distance between the object and the mirror is same as the distance between the image and the mirror. Let me give you guys an illustration. Let's say we're having a mirror like this. Let's say we're having a mirror like this. Okay, this is the mirror. This is the mirror. And then a person stands in front of the mirror. Okay, this person stands in front of the mirror. From here to the mirror, okay, if we call the distance between the person and the mirror u, if you call the distance between the person and the mirror u, okay, the person is going to see an image that is formed inside. This is the object. The object is whatever is placed in front of the mirror. Now this person is going to see an image formed inside of the mirror. Okay, so there's an image formed inside of the mirror. So when you look inside the mirror, you are going to see an image formed inside of it. Okay, exactly the same thing. Okay, that is why when you stand in front of a mirror, a good mirror, a mirror that is not broken, okay, you notice that you are seeing exactly yourself, right? Your color is the same, your facial look is the same, and every other thing is the same. Okay, so that is what we want to take note of. What you notice that the distance from the person to the mirror is same thing as the distance from the image to the mirror inside of it. So if you move backwards in your plane mirror, take note of in your plane mirror, just in case maybe you don't have a plane mirror in your house. Maybe you have another kind of mirror that I don't know. Okay, now if you stand in front of a plane mirror, the distance between you and your plane mirror is equal to the distance between the image in the mirror and the what now? The mirror. Here's what I'm trying to say. From here to here, that is from you to the mirror, is same distance as from this image to the what now? To the mirror. So if from here to here is u, from here to here is v, it means that what now? U is equal to v. Now you cannot take note of one of the properties of a plane mirror. Take note that one of the properties, okay, of a plane mirror, one of the properties of a plane mirror is that the object distance is equal to the what now? The image distance. That is how you take note of it. You don't have to cram anything. Okay, is that number one, the object distance, okay, the object distance is equal to the image distance. Okay, the object distance is equal to the what now? The image distance. Take note of this. Examiners are going to ask you this, especially JAMB, okay, or WAEC examination. Okay, object distance is equal to the what now? To the image distance. You don't have to cram it, I just explained. Okay, now what else do you notice? The height of the person is same thing as the height of the image that is being formed. Okay, the height of the person is same as the what now? The height of the image that is being formed. which means object height is equal to what now? Image height. Okay, so number 2 we can say that object height, okay, object height is equal to the image, okay, to the image height. Okay, let's just put it that way. To the image height. That is, if we call the height of the person standing here, okay, this person here is an object. Not in English language now, we're talking about physics. Okay, so this person is an object because the person is placed in front of the mirror. Okay, so from here to here, we are going to call it what now? Object height, OH. Okay, and from here to here, we are going to call it what now? Image height, IH. So we are basically saying that the height of the object, OH, is equal to the height of the what now? Of the image, IH. Okay, that's what we are saying. So U is equal to V and OH is equal to what now? IH. What else do you notice whenever you are standing in front of a mirror? Now you cannot think of it because what we are having here is actually what we see or experience in our everyday life. Okay, so what else do you notice when you are standing in front of a plain mirror? A plain mirror, that's what I'm saying. Apart from object distance is equal to images, and what else do you notice? Object height is equal to what now? Image height. What else do you notice? Now you also notice that there is something we call lateral inversion. Lateral inversion. Now, lateral inversion does not mean upside down. Take note, it does not mean upside down. There are some surfaces you look at and you'll be seeing yourself upside down, not a camera. Okay, those surfaces are usually curved. Okay, those curved surfaces, they form either the two kind of mirrors that I have not defined under curve. Take note. Okay, now another thing you notice about standing in front of a plane mirror is that it is laterally inverted. But what is laterally inverted? You notice that when you are standing in front of a mirror like this, if you raise up your right hand, since you and the image inside of the mirror, you guys are exactly the same. If you raise up your right hand, that image in the mirror is supposed to raise up its own right hand now, right? So if I'm raising up my right hand, since we are exactly the same, you should be raising up your own right hand. But you notice that when you raise up your right hand, from your own perspective, the image is going to raise up what now? Its left hand. So it's going to raise up its left hand like this, right? So when I raise up my right hand, instead of you raising your right hand to, you then raise up your left hand. Okay, that is what we call what now? Lateral inversion. Okay, so as I'm standing here, I raise up my right. The image raises up is what now? It's left. Okay, so number 3 property you should take note of. The image formed in front of a plane mirror is what now? Laterally inverted. Okay, it is what now? It is laterally inverted. Okay, now if I remove this laterally and I put just inverted, it will mean that it is just turned upside down. So when we say it is inverted and there's no lateral in front, okay, no lateral. If we don't put lateral in front, it means we are saying that the image is turned upside down. So if I place the marker in front of the mirror, I will not sit like this. Or if I place it like this, I will sit like this. That's what now inverted means. But as far as I put this lateral here, it means we're not talking about top to bottom. We're not talking about left to right. Okay, we're not talking about what now? Left to right. So it is laterally inverted. Now, there are some other properties you can take note of. I don't necessarily need to write them here. Okay, size of the object is same as size of the what now? Of the image. So if you are fat, you don't expect to go into a mirror and look at yourself and you'll be thin. It is not magic. So if you are thin, you don't expect to go into a looking mirror, a plain mirror, and look at yourself and expect yourself to be fat. Or if you are skinny, you don't expect yourself to be muscular. Okay, that is the same size. So object size is same size as the image. Okay, so I can come here and write number 4. Object size is same as image size. Okay, object size is exactly the same as the what now? As the image size. What else do you notice? Any other thing you can notice whenever you stand in front of a plane mirror, you can add it as the properties. But trust me, if you are asked in an examination, these are the most common ones that you should expect. Okay, you should expect these properties to come out as part of your questions in an examination that has to do with plane mirrors or mirrors or thereabouts. Okay, now we just described one aspect of the mirror, which is the what now? The plane mirror. Which is the plane mirror. Okay, what about the curved mirror? The curved mirror can be broken down into 3 parts. Take note, a professional examination will likely not ask you how many kinds of curved mirrors we have. They will not ask you. What they will ask you is to describe various properties of one of the curved mirror. They'll pick out one and they tell you to describe it. Do you know why? Because many books classify curved mirrors as 2. But for me, I actually classify it as what now? As 3. Because there's also one that we should not just kick out of the book. Okay, now I'll write out the three kinds of curved mirrors we have. Okay, now the first kind of curved mirror is the concave mirror. The concave mirror. The second one is the convex mirror, and the third one is the parabolic mirror. Okay, the concave, the convex, and the parabolic mirror. Okay, so basically these are the three kinds of curved mirrors we have. Why most textbooks are going to eliminate this parabolic, to put just concave and convex. Okay, but it's important that you take note that we're having what now, three kinds of curved mirrors. Okay, now the next thing we want to do is talk about the properties of these curved mirrors. Okay, that's the next thing we want to do. Okay, talk about the properties of these curved mirrors. But before we go in depth into the properties or the kinds of images that are being formed, which is our main topic for today, let us describe the curved mirrors. Now, as their name implies, concave, convex, and parabolic under curve, it means these three mirrors are what now? Curved in shape. Okay, they are what now? Spherical in shape. When I say curve, I'm not talking about a circle. Okay, in this case, I'm talking about a spherical shape. Okay, so these three guys, they are what now? Spherical in shape. The first one here, the concave mirror, is what we're going to talk about. Okay, so let's talk about number one, the concave mirror. So for number one, we're having a concave mirror. Okay, now it is something like this. Okay, it is a mirror like this. It is curved. Okay, it might not be exactly bent like this when you see one in real life. Oh, take note. Okay, it might just be a little bit bulge. Okay, so you are seeing my palm like this. My palm is straight, right? If I should curve my palm a little bit, this part is bulge, right? If I should straighten it a little bit, it is still curved. Okay, but not as curved as this. Okay, so expect the mirrors to look like this. Okay, example. I really don't want to go into the example that is coming to my mind yet because it is under the convex mirror. That's one that you guys have been seeing. But you might not know that it is convex mirror. So when I get there, I'll give you the example. Okay, so keep it in mind. What we're having here is a concave mirror. Okay, now for this concave mirror, it is the inner part of the mirror that is inside that reflects what now? Light. It is this part that forms an image as well, which means, or in fact, take note, generally, whenever we coat one side of a mirror, when it is silver coated, we use silver to coat it. Okay, usually silver nitrates for the chemistry students. Okay, we use silver nitrates to coat it. But since I'm not talking about chemistry, let's just make use of silver. Okay, I don't want to get you guys confused. When you're watching my videos on chemistry, then you can now take record of that. Okay, now when you coat one part with silver, the other part becomes the reflective surface. So if I should pour silver on this part, let's say this one is a glass or anything, any surface at all. If I should pour silver on this part, this inside part will now reflect as a mirror. That's what happens. If I should pour silver inside of this part, it will be the outside that will reflect. That's how it is. Okay, so for a concave mirror, the outer part is what now? Silver coated, and inside of the mirror what now? Reflects light. Okay, that is how you describe a concave mirror. Okay, now another peculiar property to concave mirrors is that they actually converge light. That is, when you put a high beam, okay, of light towards this guy, although the intensity is going to decrease slightly, okay, but what they actually do is they converge the light. Okay, when a light ray hits this guy like this, the what now? Converge it. Okay, that is, if the light ray is parallel to it, oh, take note, if the light ray is parallel to it, so if the light ray is coming like this, the light rays are coming like this. Okay, take note, they are parallel to a particular line that I've not talked about. There is a lot to learn on curved mirrors, so kindly follow me smoothly. Okay, step by step, don't be in a rush. Okay, there's a lot to talk about. Now these rays are what now? Parallel. Okay, so let's say an imaginary line. Let's put that imaginary line. This line has a name, but I'm not going to mention the name yet because I want to go step by step. Okay, so let's say this beam of light, they are all parallel to this guy here. Anytime they hit this surface, they will always what now? Converge to a particular point. Okay, anytime they hit the surface, they will converge to a particular point. Converge to a particular point. Converge again. Converge again. Converge again. Now this point that they are converging, whenever beam of light travel parallel to this imaginary line, it has a name too. Okay, many things have names. I've not talked about them yet, but I will certainly talk about it. Okay, now what is peculiar about this concave mirror? Let me write the name under. Okay, a concave mirror. What is peculiar about the concave mirror is that whenever light rays, light rays become beam. Okay, because rays in plural form, that is lots of rays become what now? A beam. Okay, whenever light rays traveling parallel to this axis hits the mirror, they always what now converge to this point, okay? That is, they pass through this point, like that, they pass through the point, okay? But they first converge here. That's what happens. Okay, now anytime you see that you point the light ray to a mirror like this and they converge, that mirror is a concave what now mirror. Okay, that mirror is what now is a concave mirror. Now this concave mirror, it has another name. Oh, it has another name. How do we remember, or how do we know the other name for a concave mirror? From my definition, I just said that whenever light rays traveling parallel to this axis hits the surface of the mirror, the reflective part of the mirror, usually what now pass through this center. I've not said the name yet. I will say it too, but I've not said it yet. Now they will pass through this center, or rather they will first converge at this center. Okay, I just make use of the term what now? Converge. I just make use of the term what now? Converge. Okay, there's supposed to be an E in the end, but the reason I'm not putting an E is because I've not completed the name. I just use the term what now? Converge, or rather, let me just add it. I just use the term what now? Converge. Now, because it converges light, we now call it a converging what now? Mirror. Because it converges light, look at it, it is pointing on the light to this particular spot. It's what now? Converging it. For that reason, we can also call a concave mirror a what now? A converging mirror. Ladies and gentlemen, we can now change this guy to what now? A converging mirror. A converging what now? Mirror. That is how you get the other name for a concave mirror. So by understanding its property, okay, by knowing how it works, how it reflects light, we can call it what now? A converging mirror. Okay, now that is that, or the definition for a concave or a converging mirror. The next one I want to talk about is number 2, the convex mirror. The convex mirror. Okay, now if you need to know one of the use of this this particular mirror, that is the concave mirror, it is used for shaving. Okay, I know most Nigerians do not use it, okay, but in the outside part of Nigeria, okay, most persons, or in most professional nice homes, okay, actually make use of concave mirror. The reason is because there's a particular distance you place the mirror from your face, and your face will become bigger, so you can see everything you are shaving clearly. Okay, but in Nigeria, most times we don't make use of that. So make use of a plain mirror. Just put this as far as we are seeing ourselves, we can shave. Okay, okay. So the best mirror to make use of for shaving is what now? The concave mirror. Now the next one we're going to talk about is the convex mirror. Okay, ladies and gentlemen, we're having the what now? A convex mirror. You might be wondering, and you might be asking yourself, sir, why are you drawing this curve in the opposite direction? That's because I want to make use of one part as the reflective surface. Okay, now remember I said for a concave mirror, we are going to coat the outer part, okay, and the inner part becomes what now? The reflective surface. But for a convex mirror, we are going to coat the inner part instead. That's the magic. They are like almost opposite of each other. I'm saying almost opposite to almost, not exactly opposite, almost opposite of each other. Now we're going to coat the inner part of this guy. Now if we coat the inner part, the outer part becomes the what now? The reflective surface. So if I'm having my palm like this, a plain mirror, if I twist it like this, okay, and I coat inside of this place, I'll be able to make use of it as a mirror. Okay, that's the trick. This part becomes what now? Reflective. Okay, and that is how we're having a what now? A convex mirror. Now for a convex mirror, the difference between it and a concave mirror is that if we're having an axis like this, okay, any ray of light that travels parallel to the axis, what the mirror does to it is that it will diverges. That is, instead of converging them to one point, is what now? Diverges them to another point. Okay, so if they strike this surface like this, it is what now? Diverge, go outward. Okay, it's here, it is what now? Diverge. Okay, diverge and diverge. Okay, so instead of them converging to a spot like this one, they what now? Diverge. Okay, now the name of this mirror is the convex mirror. The convex mirror. Okay, now smart students, let's see how we are prepared for whichever examination you are preparing for. Okay, if this guy, the concave mirror, is also called the converging mirror, by definition, the convex mirror will also be called what? You can pause the video and drop your answers in the comment section. Okay, convex mirror will also be called what? The concave mirror converges light. The convex mirror diverges light. So what do you call this guy? You can now call it a what now? A diverging what now? Mirror. A diverging mirror. So ladies and gentlemen, in your notebook, add the names to it. Okay, a convex mirror, or what now? A diverging mirror. Okay, you can either call it a convex mirror or you can call it a what now? A diverging mirror. Very, very easy to understand. Okay, trust me with my explanations, you should be able to understand all of these things. Now, to not miss out on more of my videos where I teach not just physics but as well as your other subjects like chemistry, English, mathematics, okay, and even those in natural sciences and arts, we have tutors for that, making videos still on this YouTube channel. Okay, so refer your friends and also make sure you subscribe to the YouTube channel Dr. Flash. Okay, so right now click on the subscribe button and also click on that bell, that notification bell, so that whenever a new video is being posted on this channel, you'll be one of the first few persons that will get notified about it. If you've not done that before, maybe this is your first time coming to this YouTube channel, ensure you do that. Okay, let's help you learn more and pass your examination. Okay, so you're having the convex mirror, also known as the what now? The diverging mirror. Okay, we're now having a third mirror here, number 3, the parabolic mirror. So for number 3, the parabolic mirror, before I go to parabolic mirror, let me give you one use of the convex mirror. Okay, one use of the convex mirror is that it is used in driving mirrors. Okay, it is used in driving mirrors. That is, whenever you are driving, those side mirrors, okay, on the side of a car, okay, they are actually convex mirror. And you notice in some of them they write objects are closer than they appear. Okay, the reason why we use a convex mirror is because it provides a wider field of view. So let's say light rays from every other distance, they are coming in like this. They are coming in like this. Okay, now this is the driver here. This is the eye of the driver. Okay, this is the eye of the driver. Okay, driving. Okay, if there is a car here, if there is a car here, if rays of light pass through the car and hits the mirror, it's what now? Travel back parallel to the driver's eyesight. If there's another car here hiding, if it hits the mirror, it travel parallel to the what now? To the driver's eyesight. That is how we make use of it. So don't think we just decided to put the mirror there. It is because of physics that we're placing it there. Okay, take note of it. Convex mirror is used. Okay, and they wrote there that objects in the mirror are closer than they appear. That is also true for a convex mirror. Okay, the image is usually smaller, and the image formed by the mirror is usually closer than what you think. Okay, that is, if there is a car, let's say 10 meters behind you, in the mirror you'll be seeing it as something less than what now? 10 meters. Okay, I'm not giving a specific number. Let's say 6 meters or 8 meters or thereabouts. Okay, it is usually what now? Closer to you than what you're having there. That is why it is said that objects in the mirror are closer than they appear in that particular mirror. It is not a plain mirror. It is not a normal mirror you have at home. Okay, that is why we are having these various properties. Okay, now next one I'm going to talk about is a parabolic mirror. Now for a parabolic mirror, it is similar to a concave mirror, but it is just like this. Okay, it is still curved. And let's say we're having an axis like this. Okay, I've not talked about the name of this axis. I'll talk about it. Okay, so don't think it doesn't have a name. I'm just putting it there. Okay, now whenever light rays hits a parabolic mirror like this, okay, these are light rays. Whenever they hit a parabolic mirror like this, okay, parallel to it too, it's going to reflect them back the same way. It's going to reflect back the same way. Okay, so imagine we're now having a mirror like this. Okay, we're now having a mirror like this, and then we place a light source here. Let's say we place a light source here. Okay, if the light source is not so bright, whenever its light rays hits the surface, what we notice is that the light rays are going to travel parallel backward. Okay, travel parallel back. That is, they are reflected backward. Okay, that is what a parabolic mirror does. For that reason, we make use of parabolic mirrors in searchlights or in a car headlight. Now, if you look at a car headlight during the day when it is not on, you notice that inside of it is coated. Okay, it can reflect, so that when the bulb is placed somewhere here, no matter the angle, okay, that the light hits the mirror at, it's going to reflect them, and the beams can now travel a far distance in a straight line. You can notice that even in some sophisticated cars, when you turn the steering, you can actually see the lights being turning, or you can choose to ask somebody to turn it, stand in front of the car, not when it is moving, no, not when the car is moving. Ask somebody to stand in front of the car, and you notice that the eyes of the cars are moving. If you turn the steering to the left for sophisticated cars, okay, when you turn the steering to the left, the lights there is going to also turn. When you turn the steering to the other side, it's also going to turn. And that's actually an improvement in terms of technology because it helps students, sorry, not students, rather drivers. Okay, I've taught a lot of students. That's why I'm mentioning students. Okay, it actually helps drivers to easily go through corners at night or during the dark. So instead of the olden days kind of car where you have to fully turn and face a corner before you can see where you're going to, by the time you turn the steering wheel, even before the whole car turn, you can already see some parts. Okay, the light will be reflecting there. Okay, that is actually an advantage. Okay, kudos to technology. So it is used in car headlights or even searchlights. Even majority of the touchlights we have, we actually make use of what now? The parabolic mirror. Even your normal touchlights, on it at night, you notice that the light is going to what now? Travel straight. But your normal bulb you have at home, if you on it, you will not see any light traveling straight. It will just be what now? Making everywhere bright. Why? The light is what now? Scattered. We are not making them to what now? Traveling a straight path by using this mirror. Okay? But trust me, if you can get a mirror like this and you place that same light bulb at the center, it's going to what now? Reflect all the lights straight. That is physics for you. Okay, so basically these are the three kinds of what now? Of curved mirrors and their uses. Okay, now before we now talk about the image that are being formed in depth, before we talk about the images that are being formed in depth, let's talk about the various aspects of the curved mirrors. Okay, that is the various parts. We're having we have what we call the poles, we have what we call the principal axis, the radius of curvature, the center of curvature, and all of that. Okay, that's the next one we're going to talk about. So once you've now understood that part in depth, you will be able to understand how images are being formed. Trust me. And if after watching this video you still do not understand, it is even impossible because there's no way you watch my videos and you will not understand. Okay, that is why, like I said, always subscribe to this YouTube channel. Okay, so the next one we're going to do, we're going to talk about the various parts of curved mirrors. All right, so the next part we're going to talk about is the various parts of curved mirrors. Okay, so I'm going to come here and I'll write the parts of parts of a curved mirror. Okay, now in this case I'm going to draw a curved mirror. I'll pick one of them. In this case I'm going to pick the concave mirror. Okay, it will make it easier for you guys to understand, trust me. Okay, I'm going to pick the concave mirror and I'll describe the parts, but it actually applies to both the concave and the convex mirror. Okay, so I'm going to come here and I'll pick a concave mirror like this. Okay, this is the curved surface of the concave mirror. Okay, and here is coated. So I'm using this one as an explanation. So don't think because I'm using the concave mirror as an explanation, it's only the concave mirror that has the various parts that I am about to describe. Okay, so this is a concave mirror. Now the first part we are going to talk about for a concave mirror, okay, the first part we are going to talk about is the principal axis. Principal axis. Okay, now the principal axis is a line that passes through the center of the curved mirror. So the principal axis is a line that passes through the center of the curved mirror. Okay, so this straight line that I'll be drawing, that I did not give a name to while making of it here, is what I call the what now? The principal axis. So this dotted line you are seeing here, all of these are the what now? The principal axis. And the principal axis is simply a straight line that passes through the what now? The center of the curved mirror. Okay, so the principal axis, I don't have to start writing out the definition. So from me saying this, you can simply pause the video and jot things down. Okay, so the principal axis is a line that passes through the what now? The center of the curved mirror. Okay, how about the next one we're going to talk about? The next one we're going to talk about is the pole. Okay, now the pole of a curved mirror is the point in which the principal axis touches the curved mirror. You see the magic? I have to describe this one first because I know I need it in the definition. So the pole of a curved mirror is the point in which the principal axis what now? Touches the mirror. So this point is the what now? Is the pole. This point that I labeled what now with a dot is the pole. That is this point where this line, which is the principal axis, touches the curved mirror is the what now? Is the pole. Okay, so this point in which the principal axis touches the what now? The pole, or touches the mirror rather, is called the what now? The pole. Okay, now the next one we're going to talk about, number 3, is the curvature. Okay, or center of curvature rather. Center of curvature. Okay, now the center of curvature, I'm going to call the center of curvature, let's say this point. Let's say it is this point. Okay, I'm going to call this point the center of curvature. Now, by definition, what is the center of curvature? You don't have to cram it. Understand what I'm about to explain. Now, this guy here is not a circle, but a sphere. It is a sphere. Take note, it is not a circle. Okay, what can I use as a description to a mirror like this? Let me use my palm, just as I've been using. Okay, this is my hand. If you look at it from the side, you will see it as this mirror here. Okay, so looking at it from the side, okay, you are seeing it as the mirror. So that's the part I'm drawing. Looking at it from the side is the part I'm drawing on the board. Okay, so in natural sense, it is like this. So if I should turn this mirror like this is what you're going to see. So there's a whole lot of surface inside, because this one I'm representing it on a 2D. I'm trying to represent a 3D on a 2D. That's why you're seeing it like this. So let's say my palm is the mirror. If I should turn it, you see the actual surface of the mirror. Okay, just like a torchlight. Look at, there's a bulb inside of your torchlight, but look at the part that looks like a funnel. That part is the curved part. Okay, so in this case, we're having a what now? A spherical mirror. Okay, now this sphere, if we should try, this is actually half of a sphere. Okay, this is half of a sphere. If we try to complete the sphere, let me try and draw something. It might not be too perfect because I'm using a freehand sketching. If we try to complete the sphere like this, okay, the other curved part is going to pass through another point of the principal axis. Now, the point where the curved part is going to pass through, which is what we call what now? This C is what we call the center of what now? Of curvature. Okay, so the point in which the complete part of the spherical mirror is going to pass through the center of, is going to pass through on the principal axis is what we call the what now? The center of curvature. So if, for example, you want to give a definition, okay, to this particular guy, okay, I'm cleaning this because I want to give some other diagrams in this. I don't want it to get spoiled. Okay, so let's say I want to describe this guy. I'll give a definition to it. From your understanding, you can try and describe it, right? You can say the center of curvature is a point on the principal axis where the spherical mirror tends to complete its other parts. A point on the principal axis where the spherical mirror tends to complete its what now? Its other parts, right? That is actually a good definition. If you can describe it in any other way, no problem, as far as you understand whatever you are describing. Okay, that is physics for you. Okay, so that is center of curvature C. Now this pole, I usually represent it as P, so I'm going to put here center of curvature. I'm going to represent it as what now? C. Now the next one I'm going to talk about, number 4, the next one I'm going to talk about is the principal focus. The principal focus. Okay, in brackets I'm going to call it what now? F. Now the principal focus is somewhere, a point like this, still on the principal axis. Okay, that is the principal focus. Now this principal focus, the principal focus is actually from this pole to this C divided by 2. So it's like the center from this pole to this guy divided by what now? By 2. So the principal focus is actually what now? Half of what now? PC. Okay, now by definition, what we notice is that whenever rays of light on this concave mirror, whenever rays of light hit this guy, okay, that they are parallel. Look at it, I explained. When they are hitting the mirror, they are parallel. They are going to pass through a particular point. Okay, that is, they are converging. If we say they are converging, it means they are stopping here. But in essence, in natural sense, they actually what now? Not just converging, but once they get to this point, they continue going like that. Okay, now that point where they are converging is what we describe as F. So we can now describe or define the principal focus as a point along the principal axis of a curved mirror where rays of light traveling parallel to the principal axis meet. Take note of it. The principal focus is a point on the principal axis where rays of light traveling along the what now? Where rays of light traveling parallel to the principal axis what now? Intersect or meet or converge. Whichever one you want to make it of, okay? That is what we call what now? The principal focus. And by experiment, we notice that the principal focus is actually half of what now? PC. Half of PC. Okay? Now, since it's half of PC, I know that a sphere must always have a what now? A radius. Right? And from here to here is actually the radius. Okay? That's what we call the radius of the sphere. Okay? From here to here, or if you trace it in natural sense, along the curve. Okay? If you trace it in natural sense, it's actually what now? Along the curve. Okay? When we perform the experiments or we do it experimentally, what we notice is that the principal focus is what now? Half of that radius. Okay, so from here to here is half of the radius. Okay, the radius is actually on the curve, like I said. Okay, and we can see the radius as what now from P to C. Okay, it's also the same thing. Okay, so we can now say the principal focus is half of that radius. Okay, very, very easy. So we can write the formula here and we can say principal focus F is equal to what now? R over 2. Take note of one formula. Take note of that formula, okay? Principal focus is radius of curvature over 2. We call this the radius of curvature. Okay? Then the other part that is necessary to describe in this diagram, no other parts. Basically, we have the what now? The poles, the principal focus, and we have the what now? The center of curvature. Okay, this R is called radius of curvature. Okay, so it is radius of the sphere. Okay, now there is still one more thing to understand before we go into images formed by what now? A curved mirror. Now I've talked about the image formed by a plane mirror. That is the first one we did. Objects, when you stand in front of a mirror, okay, what you see is same thing as what the mirror produces. Okay, or rather the distance from me to the object to the mirror rather is same thing as the distance of the image to the mirror. Okay, like that. Okay, we talked about the image formed by a plane mirror. Okay, so I've talked about this guy. What we now want to talk about is the image formed by what now? A curved mirror, particularly for concave and convex. That's what you should be expecting in your examination, especially the JAMB or WAEC examination. Okay, now before we talk about that, let's talk about how we are going to form those images rather. Let's talk about how we are going to form those images. Okay, now to create an image, take note, before an image can be formed, okay, before an image can be formed, rays of light needs to intersect. So if, for example, a ray of light is traveling like this, it will not form any image until any other ray of light what now intersect it. If another ray of light, let's call this one A, let's call this one B. If this one intersects it here, we are going to have an image what now formed here. If there's a ray of light that intersects it here, the image is going to be what now formed there. So it is where the rays of light intersect that an image is going to be formed. I'm taking these things step by step because I want you guys to understand. Whenever I go to the crucial part, which is the one that is most, which is the aspect that is most problematic for students, that is the formation of image or on a concave or on a convex mirror. Take note. Okay, so let's talk about the rays of light, how they intersect and how they are going to form images. Okay, now there are basically a few rules I want you guys to take note of. The first rule, Roman figure 1, the first rule I want you guys to take note of is that if we're having a curved mirror like this is our principal axis. If we're having a curved mirror like this, whenever a ray of light travels parallel to the curved mirror, okay, this is the pole, this is F, this is C. Whenever a ray of light travels parallel to the principal axis, look at it, this is principal axis, and the ray of light is traveling parallel to it, okay, it is always going to reflect through the principal what now? Focus. The principal focus. So whenever a ray of light travels through like this, so even if the ray of light travels through from the bottom, okay, so even if the ray of light travels through like this, let me give another instance. Let's say it travels through like this, okay, this is O, this is F, this is C. Even if it travels through like this, it is still going to what now? Reflect through, okay, it's still going to reflect through. Now the reason why this is correct or why it is true is because of the principle of reversibility of what now? Of light. The principle of reversibility of light states that if light can travel through one part, okay, the reflected ray can also travel through that same part. Okay, so if this guy is coming like this and it's passed through the part, it means if we are to shine light through this part, it's also going to what now? Reflect through like this. Okay, that's the principle of reversibility of light. Okay, now take note of that. Also, Roman figure 2, if we're having a curved mirror, okay, this is our principal axis. So here is the pole, here is the principal focus, and here is the what now? The center of curvature. Okay, now another rule is if the ray of light hits the pole, okay, if the ray of light traveling and hits the pole like this, if it hits the pole, it is going to reflect back the same way. It's going to reflect back the same way. So as this guy hits the pole here, it's going to what now? Reflect back the same way. Take note of this is another rule. Also, if it comes like this, hits here, it's going to what now? Reflect back the same way. Okay, now the third one we're going to take note of. For having a curved mirror like this, and this is the principal axis. Okay, let's say this part is the pole. Okay, this part is the principal focus, and here is the center of curvature. Okay, let me make this one bigger. Okay, principal, we're having the pole, the principal focus, and the center of curvature. Now for this particular rule, if a light ray passes through the center of curvature like this, it has to be straight. So if a light ray passes through the center of curvature like this, if the light ray passes through the center of curvature like this, once it hits the reflective surface, it is going to reflect back the same way. That is, as it hits here, it is going to pass through the same what now reflective part that was straight initially. That is, as it comes here, passes through C. As far as it passes through C, so once it hits here, it's going to what now pass through this guy the same way. Ladies and gentlemen, these are the three ray diagrams that we use in determining the position and the kind of image that is being formed in a kind of mirror, a particular kind of mirror, which could be either a concave mirror or a convex mirror. Okay, so I'm not going to clean this part. I'm really going to take out this part for us to picture the various kinds of images that are being formed for a concave mirror. So we're going to use these guys to draw them. Now what I want you guys to do is practice these things all the time so that you will be able to identify or describe the kind of image that will be formed in your mind. Okay, even without drawing these things. Imagine you ask a question in the JAMB examination and they ask you, when an object is placed at the center of curvature, what are the properties? You now start carrying your biro and start drawing. No, it will not make any sense. But if you have practiced these things lots of times in your past questions and you've practiced many of these things in my videos, it will be easy for you. You don't have to carry your pen and start drawing. You can know that, okay, when an object is placed at C, it is formed at C as well. It is what now inverted. It is the same size as the object. It is real. All of these things I just said, they are 100% correct. Why is it 100% correct? I have them in my head. I've practiced them before. Okay, that is the trick to all of this. Okay, so I'm going to look at this part and I'll go straight to the images that have been formed by a concave mirror. So for image formed by the curved mirror, in particular the concave mirror, okay, I have to move the ray diagrams to this part so that I can make use of this whole space, okay, to get a wider field of view. Okay, now those are the laws we are going to be making use of. Okay, now for the first one, what I'm going to do, I'm going to place the object beyond C, and then after beyond C, I'll place it at C. After C, I'll place it between F and C, and then I'll place it at F, and then place it between P and F. Okay, so I'm going to get the various images of the guys that will be formed. Okay, that will be about how many images? 1, 2, 3, 4, 5. So there are 5 images we are going to be forming in this particular video. Okay, so I'm going to come here and write images formed, okay, by a concave mirror. Okay, so images formed by a concave mirror. Okay, the first image that will be formed, one will place it beyond C. Okay, one will place it beyond C. So this is the curved mirror and this is our principal axis. Now this point is our pole. Okay, this point is our principal focus. Let's extend this line. Okay, this point is our center of curvature. Okay, what we are going to do is we are going to place the object, beyond C. Okay, beyond C means outside C, that is after C, that is where we are going to place it. Okay, so I'm placing the object beyond C. Okay, what we are going to do is make use of the ray diagram. The first one I'm going to make use of is this one. You can actually make use of any one, whichever works for you. Okay, in this case I want to make use of what now? This one, and see where the image will be formed. Remember I said an image is formed at a point where rays of light intersect, right? So we don't need just one, we need more than one ray, okay, to pass through this object before we can tell where the image will be formed. So the first one, the ray of light is going to what now? Travel parallel to the principal axis and then reflect back through the what now? The principal focus. So if the ray of light travels parallel, let's make use of a ruler so I can draw it straight. If the ray of light travels parallel to the principal axis, okay, okay, good. The ray of light travels parallel to the principal axis. Let me put an arrow to indicate that it is what now traveling parallel to this what now. As you can see, these two lines are parallel. And take note, it must touch the object. So if it does not touch the object, it is null and void. Okay, so it must touch the object. Now the rule says when it travels parallel to the principal axis, it must reflect through the principal focus. right? So this guy is going to what now? Reflect through the principal what now? Focus. Okay, it's going to what now? Reflect through the what now? The principal focus. Like I said, an image is formed where two or more rays of light what now intersect, right? So we don't need just one. We have to what now make use of another one. The truth is we can actually make use of this one in another form. Okay, we can make use of it in another form. That is, we can also pass this through F and expect it to reflect through what now? Through C. That's one method we can make use of. We can also choose to make use of C. If we make use of that C, but let's try and make use of C and see if we will get it. Okay, remember it is the reflected ray, not the incident ray. Okay, if a ray of light passes through like this, okay, and it comes back, it will not form an image because it will not intersect with this guy. Okay, but let us try. If we should try this number 2, if it passes through like this, it's going to reflect back through like this. It will not touch, so we cannot mix of that one. But if let's mix of number 1 in the inverted form, okay, that is, we're going to pass the ray of light through the principal focus and expect it to work and reflect like this and see what we're going to get. Okay, so let's make use of it. Okay, now this is the ray of light. It reflects, it passes through the what now? The principal focus. Notice that it's also touching the object. So once it passes through the object, it will pass through the principal focus and then what now? Reflect parallel. Remember the rule is, if it reflects parallel to the axis and touches the mirror, it's going to reflect through the what now? The principal focus. The same way, if it passes through the principal focus, it's going to what now? Reflect parallel. Okay, so that's what we're having here, but in this case under it. So once it passes through F, it's going to what now? Reflect parallel to what now? The axis. It's going to what now? Reflect parallel like this. Okay, now here is now the image. This is the object, but where is the image? What we are going to notice is that the two rays of light intersect here at this point. This is where they intersect, right? And it is where, or rather it is the point in which the rays of light intersect that the image is being formed. Okay, so at this point where they intersect, we are going to have an image. Since it is under the line, we are not going to draw it upright like this. We are not going to draw it upright. Since it is under the line, we are going to draw it upside down. Why? They are intersecting under the line. Okay, so we are going to have what now? An image like this under the line. Okay, so for this particular diagram, the image is placed beyond what now? Beyond C. Beyond C. Okay, so whenever it is placed beyond C, what do we get? What are the properties? Notice that the image is not upright, it's what now? Inverted. So we can say number 1, the image is what now? Inverted. These are the properties of the image, and that is how we get it. This is what now? Inverted, upside down. Okay, the image is inverted. Now notice that this object, it is bigger than what now? This guy here, right? Since this guy is bigger than this one, we can say it is what now? Diminished, right? It is diminished. That is, the size has reduced. This one here, this arrow here is bigger than this one. So we can say what now? It is what now? Diminished. Okay? It is diminished. What else can we conclude? What else can we conclude? Okay? Now, there's what we call, there are two kinds of image. We have the real image and we have the virtual image. Now, a real image is an image that is formed on the same side as the object. That is, this object is on the right side and there is an empty space on the left side. Okay, if the image will form is still on the right side, just like this one, we say it is what now? Real. If the image is on this other side, that is after this mirror like this, we say it is what now? Virtual. Take note, since this object is on this same side, we can say the image is what now? Real. Since the image is on this same side, we can say it is what now? Real. Okay, now what if you are asked the position? It is formed between what now? F and C. Okay, so what will be the position? It is formed between what now? F and C. Okay, it is formed between F and C. Ladies and gentlemen, that is how we describe or identify the image that is being formed, okay, whenever an object is placed beyond F. Okay, so it is formed between F and C. It is what now? Inverted. It is diminished. Okay, now it is real. And what else? Okay, those are the 4 basic properties of the image that is being formed. So you see the Venn diagram, we're going to attempt another one. So the next one here is what now? When, like I said, we're going to move it after placing it beyond C. We're going to move it. This time we're not placing it at C. Okay, so when the object is placed at C, what will be the properties of the image? What we're going to do, we're still going to draw the same concave mirror. Okay, we're going to draw the concave mirror. So we're having the concave mirror like this. This is the principal axis. Right here, we're having the pole, we're having the principal focus, and we're having the what now? The center of curvature. So we have moved the image from here to what now? C. We have moved the object rather, not the image. This is the object. So I move it from what now? Here to what now? C. Okay. So this is the what now? This is the object. We apply the same rule again. Let us pass this ray of light through this guy. What are we going to get? Okay. If we pass it through this guy like this, right? It is traveling parallel to the principal axis. So it is going to what now? It's going to reflect through the principal focus. It's going to reflect through the principal focus, right? So as it reflects through the principal focus, let's try and draw this thing so it will be straight. Okay, let's make it straight. Okay, passes through the principal focus. Okay, now remember we have to add an additional one, right? For us to get the points or for us to get the kind of image or know the location of the image. Okay, now if we make use of which other rule can we make use of? If we make use of C, you just need to pass through like this. It will not touch. We need the one that will make use of like what now? Touch. If we make use of this one again, okay, if we make use of it again, what are we going to get? If let's say passes through what now? F, it's going to what now? Reflect parallel, right? It's going to reflect parallel to the what now? To the principal axis. Okay, so if the light ray passes through like this, remember the light ray must always touch the object first. Oh, if it does not touch the object, it is null and void. You are doing what now? Nonsense. Okay, so as it passes through like this, it's going to what now? Reflect parallel to the principal axis, isn't it? It's going to reflect parallel to the principal axis. Right? Going to reflect parallel to the principal axis. I'm trying to make sure, since it is not to scale, you are most likely to get it wrong if you are not used to it. Okay? The reason I'm adjusting is because I know where it's supposed to lie. Okay? So as it passes through the principal focus, it reflects back parallel to the principal axis. Now, where do the light rays intersect? Here, right? They intersect what now? Here. So this is where it intersects here. It intersects here. Okay, so this is where the image will be formed, where they intersect, right? This is where the image will be formed, right? Where they intersect. Okay, notice I have to do a lot of cleaning because the lines are not straight and this is not to scale. If you do it to scale, if you can get an exercise book and then you make use of a ruler, do it to scale, you should be having the answers without errors. Okay, now what we are going to have is an image that is formed at this point. Okay, so the location of the object, first of all, is what now? At C. So when the object is placed at C, that is at the center of curvature, what are the properties of the images that are being formed? Okay, what are the properties of the images that are being formed? First things first, property 1. Okay, figure 1. The object is upside down, right? It is formed under the line. That is why we are drawing it like this. Because it is formed under the line. Okay, so it is what now? Inverted. Okay, so the object is what now? Inverted. Now, what you notice is that from here to here, same as from here to here, the size of the object same as size of the image. So we can also say that image size is same as object size. Okay, so image size is same as object size. Okay, what else do you notice? What else do you notice? Remember I said if the object is formed on the same side as the what, if the image is formed on the same side as the object, it is real. If formed on the opposite side of the mirror, it is what now? Virtual. Okay, so on this side is where the image is being formed. So it is what now? Real. So we can say it is what now? Real. Okay, what else do we notice? Okay, from this one, it is what now? Inverted as well. It is not diminished. This one is diminished. That one is what now? Same size. Okay, it is real. Now what about the location? It is formed what now? At C too. So the object is also formed what now? At C. So we can say formed at what now? At C. So those are the properties that are exhibited or that are seen whenever an object is placed at what now? At C. Okay, now let us now check for the third one. Okay, what about when we now move the object from C to between F and C? Okay, from C to between F and C. Okay, so this is the mirror here. This is our principal axis. Here we have our pole. Okay, here we have our principal focus, and here we have what now? C, center of curvature. Okay, now if we place the objects here, if we should place the object here, what are we going to get? First things first, we know a ray of light will travel parallel to it, okay, and then pass through the principal what now? Focus, isn't it? Travel parallel to it and then pass through the what now? The principal focus, right? Now let us try and extend this. Okay, now to get where the image will be formed, we are going to pass another ray of light. Let's pass it through F again. Okay, let's pass it through F. Or we will make use of F of this one quite a lot. So I've not even touched this one and this one. The truth is, if I make use of this one, I'll get the same answer. But since I've not even made use of number 2 and number 3, I want to make use of another one. So I'm going to make use of what now? This number 3. Okay, but because most times in most books you find, they always make use of number 3. Most persons don't even use 2. Okay, these 2 are the ones that they usually make use of. Okay, so for this one, let's pass it through C. Okay, I'm going to expand my image so that the rays of light can touch my drawing rather. Okay, so if the ray of light passes through like this, if it passes through C, okay, now if the ray of light passes through the object like this, it will what now? Pass through C and what now? Reflects back the same way, right? But if you trace it, notice that these two guys are going to touch somewhere, right? They are going to touch somewhere. Okay, now whenever they meet, that is where we are going to have what now? An image. So there will be an image formed here. Okay, upside down again. So if you are asked, what are the properties of the image that is being formed? What will be the properties of the image that is being formed? First is first, it is upside down. Okay, now here is the location. So when the object is placed between F and C, okay, objects between what now? F and C. So when the object is placed between F and C, what do we get? Okay, object placed between F and C. First is first, it is inverted. Roman figure 1, it is what now? Inverted. Okay, Roman figure 2, it is what now? Real. Why is it real? It is formed on the same side as the what now? As the object. Okay, Roman figure 3. What else do you notice? It is magnified. Notice that the image is what now? Bigger than the object. Look at the size. It's what now? Magnified. Okay, and Roman figure 4. What else? What is the position? It is formed beyond C. Okay, formed beyond C. Now, what is the magic or one trick you should take note of? This guy is the opposite of the first one. Why? The first one, when we place it beyond C, it became smaller. It was still inverted. It was what now? Diminished. It was real and between F and C. But when we now place it between F and C, we'll now get what now? This guy. Okay, we'll now get this guy. That is, if we place it between F and C, we'll now get what now? Inverted. Okay, we'll get what now? Real too. But the opposite one is now that it is what now? Magnified. And it's what now? Beyond C. When you place it beyond C, you get what now? Look at what I'm trying to say. When you place it beyond C, you get what? Diminished, and you get between F and C. When you now place it between F and C, you get what now? Magnified, and what now? Beyond C, the opposite. Okay, trust me, you're going to understand this one better by the time you practice more problems. Okay, so for this particular one, it is placed what now? Between F and C, and this is the property of the image that is being formed. Take note of this particular trick because most examiners will ask you, e.g. JAMB examiners. So take note of this. Okay, now the next step we're going to do is place the object. We'll move it from between F and C. I'll place it at F. Okay, when we place the object at F, what do we get? Okay, when we place the object at F, what do we get? I'm going to take out some part of the board. I'll take out that part. Okay, since you're already acquainted with it. Okay, you should have drawn those ray diagrams on your books. Okay, so I'll place it at F and see what we are going to get. All right, so we're going to do number 4. That is, we are placing it at the principal focus. Okay, so when we place it at the principal focus, what do we get? This is the mirror. Okay, this is our principal axis. Okay, we have P, we have F, and then we have C. Okay, so now we are placing the objects here. Let's apply the same rule. I've cleaned the rule, but because I've made use of it several times, I'm assuming that you guys are going to have it in your notebooks. Okay, so what we're going to do, we're going to pass a ray of light parallel to this principal axis. Okay, a ray of light parallel to the principal axis. Okay, a ray of light parallel to the principal axis. Look at it. Remember, it must touch the object. Okay, so as it passes through, remember the rule, it passes through what now? Through the principal focus. It passes through the what now? The principal focus. Right? Passes through the principal focus. What else? What else? Okay, now what else do we notice? We don't form an image until we pass another ray of light. Okay, now one thing about whenever an object is placed at F is that no matter where we pass the ray of light, it will not intersect this guy. That's the truth. No matter where we pass the ray of light, it will not intersect it. So even if I choose to make use of root 2, so if I make use of root 2, and the light ray strikes the pole, okay, if I make use of root 2, it strikes the pole, it is going to what now? Emerge like this. Okay, it is not going to be what now? It's not going to intersect this guy. It is going to rather be parallel to it. That is, this ray of light will be parallel to this ray of light. That is what we'll notice. Okay, no matter how we try, it will not what now? Intersect. If I also try to make use of the third rule, okay, that is if it passes through C, okay, if the ray of light passes through C, okay, if it passes through C, remember it will reflect back the same way, right? If we also trace it, it will also not what now? Intersect this ray of light. For that reason, whenever two rays of light are parallel and we cannot find the points where they intersect, in that case, we say that they intersect at infinity. That is what we say. So for this particular case, the image is placed what? The image is placed as what now? At F. Since it is placed as S, we can say that the what now? It is formed at what now? Infinity. First one, formed at infinity. Formed at what now? Infinity. That's the first thing we say. It is formed at infinity. Why? Because the rays of light, no matter how far we trace them, they don't intersect. You might be thinking, sir, when you trace these guys, they are going to miss according to your drawing. That's because I'm doing a freehand sketching. I already understand it. I've done the experiment. That is why I know that they are not going to miss. It's because I'm using my hand to draw it. That is why you might be thinking they are going to intersect. Okay, they are not actually what now? Intersecting. When you draw them to scale, make use of a ruler. Okay, so it is formed at infinity. Why? The rays of light are what now? Traveling far and they are not intersecting. Okay, now the next thing we are going to say, what is the position? What is the position at infinity? Okay, now you say, if the image real or virtual, it is what now? Real. Why? Infinity is on this side. It is what now? Real. So it is what now? Real. Take note. Now the next one you're going to take note of is, what other property do you take note of? Would it be magnified or diminished? If, for example, this is infinity and we draw the objects from here to here, what do you think will happen? It will be bigger than this guy. So it is what now? It is magnified. It is what? Magnified. Take note. It is what now? Magnified. And then, what else? Is it inverted or upright? It is inverted. Why? It is formed under the principal axis. So it is what now? Inverted. So even if you cannot see it, we already know the property of the image that will be formed. That is what now? It is inverted. It is formed what now? Under the principal axis. Okay? That is number 4. Okay? Now, how about when we place the object between F and P? Okay? When we place the object between F and P, number 5. When the object is placed between F and P. Okay? So this is the concave mirror, our principal axis. This is the pole. Okay? This is the principal focus. And this is what now? The center of curvature. Okay? When we place the objects here that is between the principal focus and the pole, let's apply the same rule again. When light rays pass through parallel to the what now? The principal axis, they are going to reflect back through the what now? The principal focus, right? Now, if we trace this reflected ray, we are going to have something like this. Why? At the back of the mirror, right? Now, for us to form an image, we need to pass another light ray again. So if we should pass another light ray, let's make use of root 2. If we should pass it like this, and it hits the pole, it's going to what now? Reflect back the same way, right? Now, after reflecting back the same way, we can now trace this guy. When we trace it, we notice that it's what now? Intersects this other light ray. Okay, for that reason, we're going to form an image here. And the image here, we're going to represent with a broken line. Now, this one is peculiar to what now? Concave mirrors. Okay, it is peculiar to concave mirrors. What are the properties of this guy? when it is placed between P and F. Okay, when it is placed between P and F, what are the properties? Okay, between P and F, what are the properties? We notice that, look at it, the image is bigger than the what now? The object. So it is what now? Magnified. So Roman figure 1, it is what now? Magnified. It is magnified because it is bigger. Okay, where is the position? Okay, it is formed at the back of the mirror. Look at it, it is formed at the back of the mirror. Roman figure 2, formed at the back of the mirror, formed behind the mirror. Okay, it is formed behind the mirror. Roman figure 3. Now I said something initially. When an image is formed behind the mirror, that is on the left side of the mirror, where the object is on the right side. Now the image is formed on the left side. When it is formed on the left side, what do we say? Do we say it is real or virtual? It is what now? Virtual. When it is formed on the same side as the object, it is what? Real. When it is formed on the opposite side, okay, it is what now? Virtual. Okay, so it is what now? Virtual. The image is what now? Virtual. What else can we say? In this case, look at it, I'm drawing it upright. In the other ones, I'll be drawing them like this. You see, I'm drawing it upright is because it is formed above the what? Above the principal axis. So the image is what now? The image is what now? Upright. The image is what? Is upright. It is not what now? Inverted. So class, basically, these are the 5 kinds of images that are formed whenever we place an object in various parts along the principal axis of a concave mirror. So taking note of it, it will most likely come out in your JAMB examination, and you should be able to answer the questions that come out regarding these aspects, because I have broken them down and I have made it easy. Now, by the time you have solved multiple problems, okay, you will now keep it in mind that whenever an object is placed at one part, the image form will have social property. So without looking at this board, I can choose to say, okay, whenever the object is placed at what now? Let's take for example TV. Whenever the object is placed between F and C, I can tell you these properties without looking at the board. Okay, first one, we know it is formed beyond C. It is what now? Inverted. It is what now? Magnified. It is real. When the object is placed at what now? Number 5. It is magnified. Okay, it is virtual. It is erect. Okay, what other thing? It is formed behind the mirror. So by practicing problems, you should be able to answer this one. Okay, let's talk about number 4. When it is placed between what now? When it is placed at F. When it is placed at F, it is formed at infinity. And it is what now? Magnified. That is, it is bigger. It is also what now? Real. Because same size as the what now? As the object. It is also what now? Inverted. How about what else? Number 2. When it is placed at C. When it is placed at C, it is same size as the object. It is formed at C. It is real. It is what now? What else? It is same size as the object. Formed at C, it is real, and it is what now? Inverted. That's 4. And how about the first one? When it is placed beyond C. When it is placed beyond C, it is what now? Formed between F and C. When it is placed beyond C, it is formed between F and C. Okay? And then it is what now? It is inverted. It is what now? What else? It is diminished. Okay? And then it is what now? It is real. Okay? So by practicing a lot of these things, practicing questions, you get used to them. Okay? Now we've talked about the 5 properties of images that are being formed from the 5 positions whenever an object is placed in various locations for a concave mirror. Let us now talk about the convex mirror, okay, and the image that is what now is formed. Now we're now going to talk about the images formed by a convex mirror. Okay, so if we're having a mirror like this, notice how I'm drawing this in the opposite direction. A convex mirror, this is the principal axis. Okay, here is the pole. Okay, here is the principal focus, and here is the center of curvature. Okay, now if I should place an object here, if you are wondering why I'm placing the object here instead of here, remember, inside of this place is coated. Hence, the outer part is what is going to what now? Reflect. Applying the laws that I gave initially, okay, for ray diagrams, okay, first one, ray of light will pass through the what now? The object, okay, and it is parallel to the principal axis. What happens is that it is what? It is going to what now? Reflect back through the principal focus, okay? But in this case, it is reflecting back imaginarily. Why? It is crossing to the other side. So we're going to use dotted lines. Okay, it is crossing to the other side. So we're using what now? Dotted lines. Okay, so this is the actual thing we get. If there is another focus here, it is going to what now? Pass through like this. Okay, it's going to pass through like this. Now, what else do we notice? So from the image, we have to make use of another ray diagram, right? So if it should pass through C, if it should pass through C, let's make use of our ruler. Okay, if it should pass through C, okay, if it should pass through C, if the light say passes through C, it's going to what now? Reflect back the same way. But notice how I'm using broken lines here. Notice how I'm using broken lines. Why? It is on the opposite side of the mirror. Okay, and remember, an image is formed where two lines intersect, right? So the image is going to be formed what now? Here, right? So for a convex mirror, when we place the object on one part, the image that is formed is what now? It is smaller. Okay, so the properties of the image is that the properties is that Roman figure 1, it is what now? Smaller, that is diminished. Okay, when it is smaller, we say it is what now? Diminished, that is the size has reduced. Now, it is formed on the opposite side of the mirror. Remember, when an image is formed as on the opposite side as the object, it is what? Virtual. Okay, it is what now? Virtual. And then again, Roman figure 3, what else? Is it real or virtual? It is virtual, right? It is what now? Diminished. What else? Now, is it inverted or upright? This is formed above the what now? The principal axis. This has to be what now? Upright. Okay, or erect. So we can say this is what now? Erect. Or we can say this is what now? It is upright. Now, if you notice, I did not write the position of the object, just like the other ones in concave mirror. I did not write the position. That's because any point we place the object in a convex mirror, any point we place the object, we always get the same kind of image that is being formed. And here is the trick you can use to remember. We call it what now? VED. V-E-D. That is virtual, erect, and diminished. This is virtual, this is erect, this is diminished. That's why I did not put upright here. Because if I should put upright here, you might not be familiar with the formula I just gave. VED. Virtual, erect, and diminished. So at any point in time that you place the objects in front of a convex mirror, you must always get a what now? A virtual, an erect, and a what now? A diminished image. Take note. For that reason, we are no longer having images formed by a convex mirror. We are now having what now? Image formed by what now? A convex mirror. Ladies and gentlemen, it doesn't end here. There's always more to learn in terms of optics. Okay. So at this point, if you've not subscribed to the YouTube channel, ensure you do that. Simply smash that subscribe button. Okay. And then click on your notification bell so that whenever a new video is being uploaded, you'll be one of the first persons that will get notified about it, whether it is in physics, in chemistry, in mathematics, in use of English, as well as your other JAMB subjects combination, and for those persons writing WAEC as well. Okay, if you have any more questions, feel free to drop it in the comment section. I'll respond to it as usual. And if you have another part of physics giving you an issue, indicate it in the comment section. I'll look at it and try to simplify the problem that it has been giving you in my next video. Like I said, don't forget to share this video with your friends, okay, and follow for more.